Hello everyone, this is Enormous with Tech Defense. This is TekTip Episode 4 on Basic Static Malware Analysis. In previous episodes, TekTip 1 and 2, we talked about basic dynamic malware analysis, which is watching the behaviors of malware to determine what it's doing. In this scenario, and where we're looking at basic static, we're instead going to be looking at the attributes of the file, and doing everything we can to that file without actually launching it, or to that malware without actually launching it. So trying to get as much information as we can without actually having it execute in your environment. Later episodes we'll talk about advanced static, which in that case we'll be running it through a disassembler, and advanced dynamic malware analysis, where we'll be running it through a debugger to step our way through the program itself. So again, basic static malware analysis is the analysis of malware without running it. We're going to do everything we can to look at the actual malware without actually executing it in the environment. So what are some of the methods that we use to do this? Well, of course, we're going to look at the hash. We're going to run it through a few AV tools, check and see if it's packed, and if it is packed, maybe unpack it, look at the strings associated with it, and of course, check out the PE headers to see what functions that it's trying to load, what dlls it's trying to bring in, and hopefully that type of information pulled together along with the dynamic analysis will give us a better picture of what's going on with the particular malware variant. Starting off with hashing, hash is a unique identifier, so every program has, again, a unique hash, and in malware world, we're usually using MD5s, but of course this could be, or anything could be hashed with any algorithm or any hashing algorithm such as SHA-1, and basically it's just changing the bit length there. But the purpose here is to have a unique string of characters associated with malware that we can then search on or store for our own purposes. So we can then compare that hash to known samples to see if anyone else has come across this hash. We can use it to share with other analysts in the malware world to let them know what we have and what we're willing to share. And of course, maintaining our own database, so when we run across something that's renamed a variant of malware you've already looked at, it'll have the same hash, because renaming the file doesn't change the hash. It's what's in the file that maintains what that hash is. So another thing we can do, besides just looking at the hash of malware, is we can also throw it through an AV engine to see if this is malware that's already been detected. VirusTotal is kind of the standard that everyone uses for this, because it'll run it across a bunch of different malware engines. But there's other services out there that for free that allow you to run a particular malware variant through several engines to see its detection rate, and if it is detected, it'll tell you what it is detected as. And all that is very useful information when you're trying to find out more about malware. So packers are kind of a subcategory of the ossification category, I guess. What it's trying to do is trying to compress the malware in an attempt to make it harder for analysts to review or analyze that actual malware. So by packing it, they can wrap it up in a nice little package that we can't get into without unpacking it first. The tools that we'll look at, or we'll use to determine if something is packed, is PID, and if it is packed, depending on what it happens to be packed with, we will then grab the unpacker to unpack it. When it is packed, it'll still try to load some you'll still see some strings, and you'll still see some DLLs that it has to be loaded, but you'll see very few limited ones, and that's almost an easy way to find out if something is packed and maybe PID didn't see it, is when you see very few strings and functions. So strings can be very useful in gathering some useful hints about what this malware is and what it's trying to do and any indicators that might be involved with it. So a string is a series or a sequence of characters, and what we're literally looking for when we search for strings are particular things that stand out to the eye, right? We're not going too deep there. We're just trying to see, can we find an IP address? Do we see a URL? Do we see a DLL? Something of that nature that, without putting too much effort into it, we can see something that's recognizable and then apply that to what we know about the malware before we go into, some of the advanced static stuff like throwing it in a disassembler to, step through the program a little bit differently. So almost all Windows executables are in a format called the Portable Executable, or PE, file format. So what's very good about this file format is the headers have great information in there that allow us to be able to analyze malware more efficiently, and of course they're there so that the malware can run. But what we're really looking for, and what we get the most information out of when we look at PE headers, are the libraries that are involved with this package, and some of the application type and stuff like that. When we go through the demo, we're going to be looking at Dependency Walker and seeing what DLLs a particular malware sample is trying to utilize, and based on those DLLs, we'll know a little bit more about what it's trying to do. That said, know what those common DLLs are used for. I'll put a reference in the slide deck that'll, or maybe not the slide deck, I'll put a reference in the video description that'll show you, a list of DLLs and what they're, commonly used for, and that'll help you understand, when you see these DLLs, how they apply to that particular sample. Alright, so now that we have a basic understanding of what we're trying to look for, let's get into a demo. So, the first thing we're going to be looking at here is the hashing. So, like I mentioned before in the slide deck, we're going to use MD5 Deep. There are plenty of other utilities that are out there to grab that can gather hashes, but this is one tool that I prefer to utilize, especially when I'm on a XP box like this. So again, a hash is a unique identifier, and when we grab this information, we can use it to search. We can use it to search for particular malware variants, or see if anybody else has this malware, if it already has names been identified, or we can just use it for simply keeping a database of everything that we've currently have, or that we've currently analyzed. So the piece of malware we're going to look at right now is this one here, dbbackup.exe. I just grabbed this one. I have no idea what it is. Didn't do any analysis on it yet. Just went and grabbed this from Minotaur. So those of you who haven't seen Minotaur, definitely check out minotauranalysis.com. It's a good place to grab some malware samples. So grab the URL, wget it, and bring it to a samples folder where you can then play around with it. So when you go to Minotaur at first, you're in the consolidated malware list. And we'll give it a second to catch up with us. Alright, and once in the consolidated malware list, you can click here to see things that are confirmed malicious versus stuff here that may not necessarily be bad. It's just being caught by some services that think, hey, this could be bad. So again, just check out this if you're trying to download samples. I know people have asked me about that before, where can you get samples? This is obviously a great place to do it. Alright, so this is a very easy part of the demo. So really I'm just going to run MD5 deep .exe, and I'm going to point it at the file that I want to have it hash. So in this case, I want to go to samples and then dbbackup.exe. So right here is the unique hash. No other file will have this hash. So if anything else has this same hash, that means it is the same thing. It is this malware variant, or this sample. So now that we have this, again, we can go check a hashing database. So Internet Storm Center has one. And we'll see no result there. We can check out the malwarehash.com, and of course we have Threat Expert, and I can throw it in Threat Expert as well. And as you can see, hasn't been found there. So this is must be something new to the street here. Typically when I check things out for Minotaurs, it's been around quite a bit. So this is something new. Of course, we then hold on to this so we can identify this malware variant later. If we're sending it around, we usually have this hash in there as well, so people can search for it easily. And that's it for when it comes down to looking at the hashing part. So next we'll take a look at some of the other things we can do, such as submitting it to an AV site. Okay, so in an attempt to save you some time, I've gone ahead and sent this through VirusTotal already, so we don't have to wait for it to upload and analyze. But just to show you how that would happen, I would go to VirusTotal, choose File, grab the one I want to add here, tell it to scan it, and because I've already done this, it's going to say, hey, this is already analyzed on a different day, or this time and this day, and it has a detection rate of 23 out of 42. It's actually pretty good. So you can take a look at the last analysis or analyze it again now. So we could reanalyze it if we want, but we're fine with the view last analysis. So again, we see our detection rate here. They also give us the SHA-256 hash if we want to add that to our database as well, but the MD5 one is fine for us. So now we can look and see what antivirus engines caught it, which ones didn't, and on what date they caught it, or what date they'd seen the update that caught this. But also we're going to see some names in here that are pretty indicative of what we might be looking at here, right? So we see Trojan, okay, we get what that means. Downloader, we get what that means. Dropper, these are terms we know here. And of course, I thought I saw one here that said right here. So that tells us, hey, maybe this thing's packed as well, and that's something we'll check out in a couple minutes here. Of course, you can see other stuff about it. The behavioral information is what we would find in our dynamic analysis. So you can see, again, what we were doing manually before in episodes 1 and 2. You can see a system like this, an automated system, is able to drop this information in a pretty standard format for you to read. So it's telling you exactly what it's opened, what it's read, what it's written, and that's all the stuff that we looked at. And here's something that we'll be looking at shortly once we look at the PE headers, which is what these DLLs are and how to see them. Alright, so now we're going to take a look at packers. Packers, or we're going to look and see if this actual malware is packed in any ways. So again, a packer is compressing a file, so we can't really tell, or we can't really do analysis on it without unpacking it first. So again, this one I'm not really sure if it is packed or not. I didn't do any pre-research on it, so let's check it out. Samples, we're going to look at DB backup. And okay, so down here it gives you what it thinks the packer is. Normally, almost all, I would say 60 to maybe 70% of the malware I look at, it ends up being UPX, and UPX luckily has a very easy unpacker. In this scenario, it looks like nullsoft pimp stub is what it thinks the packer is. From previous experience, I know that this is not a packer. It's more of a scripted install package that is used. One good thing to note on this, though, that I found out last time is you can actually extract nullsoft pimp stub executables with 7-zip or whatever zip tool you use. So if I extract files, let's just open archive. So unlike most malware, I can actually just go ahead and take a look at what DLLs it's shipping with. And again, this is stuff that is very telling about what this malware may be up to. But we'll get into that more when we're taking a look at dependency walker. So I'm not going to go into that right here. But for this scenario, it looks like we lucked out and it's not packed. So we'll move on to strings. Okay, so now we're going to take a peek at strings. So in order to do this, download a tool for it. The one I'm using is actually called Strings. And to show you what it does, let's go to CD Tools. I believe it is CD Static, then Strings. Okay, so in the strings directory, I'm going to run strings.exe on C samples dbbackup.exe. And because strings are usually long, I don't want to run it in here. I'm just going to send it to the samples directory where I can pipe it over there to the samples directory where I can look at it. Samples, and we'll just call it strings.txt and run. So we should see now strings over here. Double click this and let's take a peek. Alright, so again, strings, we're just trying to pull out relevant strings of data that we can recognize, right? So all this stuff we don't care about. It's not a valid string, or maybe it's packed, maybe it's obfuscated, or maybe it's just not a string, right? So let's scroll down a bit and see if we can find anything in here that is worthwhile. If we don't see any valid strings in here, it means maybe it is packed and we just missed it and it didn't get caught. But I don't think that's going to be the case in this one. Right, so which we can start telling already. Okay, so now we're going to start getting a quick feel for what it's trying to do, or at least what strings are in the malware, so we can start seeing if it's looking for a particular DLL or a particular URL. But right now this kind of looks to me to be mostly that installer portion, the nullsoft thing that we were seeing earlier. So we're going to go ahead, keep diving through a little bit, and I'll stop once I see something. Right, so we're looking at the installer still. And now, yep, we're still in that installer, that NSIS that we saw when we were checking out PEID. And we're not necessarily to anything that would cause concern yet. Keep going. So now we're starting to get into it. Okay, so now we see a URL, and if you remember when we checked out Threat Expert, I think I remember, oh no, when we looked at VirusTotal, I remember seeing that, and I do, right? So when they did the behavioral analysis, they saw it trying to go to that particular URL. Okay, so now we're seeing that. That starts making a little more sense to us. Start seeing some of the other executables it's referencing. And so this is interesting, right? So now we're looking Capsule Labs, Kingsoft antivirus, Norton security status. So to me, this says maybe it's looking to see if you have any antivirus installed and perhaps behave differently if you do have any of these particular antivirus programs installed on your machine. And here, another one, virtual machine. So maybe it's looking again to see if you're running on a virtual machine, because perhaps that means you're trying to do some analysis, and if you are, let's behave differently. Or maybe it's just the way this nullsoft installer works. I'd have to take a look at the installer itself, or the scripted installer, to see if maybe it just adds this stuff by default. So here's some other good stuff. Alright, so Blowfish, that tells me there's going to be some encryption involved. And hopefully neither of those are the password. And we saw a bunch of DLLs up there, and I'm just scrolling past all the stuff that we don't necessarily care about. And as you can see, we're only about halfway through this thing, and we've already got a decent amount of information. So now we start seeing net use add, net use delete, some of the commands that this might be trying to leverage. See some more DLLs, but we'll see more of that in dependency walker. Right. So now we're seeing some good information. And I should mention that based on the name of the sample, DB backup, I would assume that this is masquerading as a backup software for a database. So that may explain some of the stuff we're seeing in here in relation to databases. So right here, right, it's doing some, I think this might even be adding a connection string to the database. We'd have to look more about where this actual file came from. So if we went to Minotaur and looked, where did that file actually come from? And we'll look at that later. But if we saw where it came from, maybe we could see where they were marketing this this file. That's obviously malware, but it's trying to masquerade as a database backup software. So if we were able to find out a little bit more about the owner of that software and what he's trying to market it to, we could understand maybe how we should set up our machine, our malware analysis machine, to get the most data out of this. So if it's looking for a SQL database or an Access database or a MySQL database, we could set one up on here when we do our behavioral analysis to see what it does to that actual database. WinRAR, moving directory, so share. So a lot of commands we're used to seeing here. But from this, again, it's given us hints, another connection string. It's given us hints about what's going on, but we can't really tell exactly. We're just, based on the strings we see, we're taking some educated guesses. We don't really know until we're in a disassembler or debugger, and then we really start finding out what's going on. SQL Server. And we'll keep scrolling through. See a lot more DLLs again that are being referenced. garbage. More strings here. So this is good. This is telling us what kind of errors we could expect, a dialog box to be presenting to a user during the install or run of this malware. Keep chugging along. Progress 1. Getting closer to the end here. Let's see what we got, if there's anything else special. Again, we're hitting up all those DLLs, most of the stuff we've seen already before. See some more blowfish. No 2 fish, just blowfish. And we're at the end, and padding. That's funny. Okay. Alright, so here we were able to actually get a pretty decent amount of information. We know kind of what DLLs are being referenced. We know what the target program to infect was. We saw URL that it was trying to get to, or that it will be trying to get to if it's launched. We know that AV, if you have AV installed, it might be a problem when you go through the behavioral analysis, and the same thing with VMware, because it was definitely looking to see if you had VMware installed, or at least making that attempt. So how it behaves once it finds it, only running it we would be able to figure that out. So during the debugging is where we'd really see that. But that covers what we wanted to see here in strings. And let's move on to the next portion. Okay, so now we have, we're going to use a dependency walker to take a look at the DLLs that are going to be imported into this particular program. So it's important to note that while we talked about examining the PE headers and the file format, PE file format in general, we're really focusing on the imports right now. But there's also exports and sections and resources that we could be taking a look at. That's a little more advanced, so we're going to stay away from that right now and just take a look at the DLLs. So let's go ahead and open up our file, DB backup. Great. So let's go ahead and minimize it all. And let's explain what you're seeing here. So in DB backup, that is the root exe, these are the core DLLs that are being imported. Over here in this section here, we get to see the functions that are being used by the particular DLL that we clicked on, or that are at least being called, not necessarily used. Down here is everything else that DLL could have done or could have called if it wanted to, but this part's not really particularly useful for us. So now you understand what you're looking at a little bit. Let's talk about these DLLs. So for those of you who may not be familiar with how DLLs work, or what they mean, each one of these kind of has a different function or different core group of functions associated with it. So for instance, the kernel is used to manipulate and access files in the memory and hard drive and even hardware a little bit. User32 is for UI related stuff like buttons. GDI is graphics related. Shell, I don't remember that one particularly, but yeah, as we can see by the very well named functions, we can start to get an idea of what shell may be doing for us. Browse for a folder. Here is ADV API or Advanced API. This is where we're looking at registry functions being called into play. .com. This one is for dialog boxes. This one's for object linking, and version is for what it sounds like. So just to take a peek through some of these, we don't want to overwhelm you, but kernel 32, for instance, some of these functions are very important to us, and we want to pay attention to them. Once we start debugging or taking a look at that disassembly. So some of these things, for instance, create process. That to me tells me that it's going to create a process that it's going to run. And that's something we need to be on the lookout for. Creating a file, we know it's going to create a file, it's going to create a directory, and we would expect it to do this type of stuff anyways, because it's supposed to be masquerading as a database backup software. But in addition to carrying out that core function, if it even does that, this also is going to be doing some malicious things. So we have to take a peek and find out, what is this stuff it's trying to do just to make us think that it's legitimate software versus what are the things that it's trying to do to actually carry out the intent of this particular malware. So delete file. So yes, these are all very well named functions that you can get a pretty good idea of what they're trying to do just by taking a peek at them. But of course, if you wanted to find out more about any of these functions, Microsoft does a great job of documenting what each of these does. So to find out more, hit up TechNet and you can see a full list of functions. Of course, if you are like me and have the Practical Malware Analysis book in front of you, Appendix A will have all of the common ones and what they do and which ones are important for you to take a look at. So that's what we see here in kernel. Of course, the other good one here is the registry. These are all very important things that we want to know about. We want to know what's deleted. We want to know what's created. We want to know if there's any new values set. So these are very important things. But you'll notice that each of these DLLs also has other DLLs that are called within it. So when you take a peek, there's really a whole lot more to look at. So to find out more about what these DLLs do, again, go to TechNet because they'll have a good listing of them. Some of these are going to be custom-made DLLs that you'll then have to pull out of the malware and really take a peek at to find out what they're doing, especially if they don't name what it's doing properly, or not properly, but don't name it in a fashion that would let you know what it's trying to do. But that is how we use Dependency Walker to find out more about these files. So now you pull all this information together and you should have a good picture of what the malware is doing. And then once you do the dynamic side of things with this same malware, and you not only know that it's trying to create registry files, but now you see it create it in the behavioral portion, you'll understand better what it's trying to do and where that was called. And then eventually, when we get to the more advanced portions of this, where we're looking at it in a disassembler, or for even better yet, looking at a debugger, and we're going step by step, watching what it does, each step of or each line of code, what it's actually doing, then things get to be very interesting. What I like most about what we've seen so far is, of course, looking for antivirus and VMware. So that tells me this could be doing some very useful things that would inhibit me from even doing some dynamic analysis with this, because I'm running on a virtual platform. And this is something I talk a lot about, which is, should you be using a virtual machine for analysis or not? And my answer is you should be doing both if you have the ability or you have the resources available to you. Because again, if they're looking out for a virtual machine and we happen to be running on a virtual machine and they decide malware will not run on the virtual machine because they believe that it could be being used for malware analysis, then we're not going to find everything that we would want to when we do our behavioral analysis portion. Now that said, maybe it has an exploit that targets specifically virtual machines. Then we'd want to know that, oh, it's looking for a virtual machine because that's the target in this scenario. Now, based on this being SQL and most people being very afraid to put any database on a virtual machine, I doubt that's the case. But you never know. And of course, because we don't know too much about that installer script that it's utilizing, perhaps this is just a function, just some core functionality, a couple checkboxes that the malware developer made or put in place when he packaged the file up. Maybe it was just a couple of extra clicks, didn't know what he was doing, and not necessarily looking for it for malicious purposes, but just because that's what that packager looks for. But that covers what we want to talk to today on basic static malware analysis. And next portions of the malware analysis series, we'll start talking about the more advanced stuff, and hopefully we'll have more for you on this particular sample next time, as I'll be playing around with this over the next couple of days to find out more about it. Alright everyone, thank you for joining me for this episode of TekTip. If you like this one, be sure to check out the previous TekTip episodes at techdefense.com, particularly the ones that have to do with basic dynamic malware analysis. Like always, you can reach me at enormous@techdefense.com if you have any questions, comments, or concerns. And hope to see you at the next one. Thanks.